Okay, hello everyone. So this is example 13.1 from section 13.2 of the textbook. Now, I'd like to do a lot more than what the book does in this example. I would like to take this data and not only compute the F statistic, which is the extent to which the extent of which the book takes this example. I would like to do a full hypothesis test. So why don't we go ahead and start with step one. Let's say that the original claim is what? That let's say we're being skeptical here and we're assuming that there is no change. All right, so you've got 3 different diet plans. They're tested for weight loss. The entries in the table are the weight losses for the different plans. So we've got, each plan is a what? What do we call that? A factor. And that's a qualitative variable. And each factor has a list of data values, and these are the responses, right? And so for plan 1, there are 4 responses. There are 4 values of the response variable, and for plan 2, there's 3, and for plan 3, there's 3. And each one of these has a mean, and what we're asking is are those means really the same? And so since we're taking a skeptical approach here, we're going to say that there is no difference in the weight loss for each plan. Okay, now whether there's a difference or not, we're just gonna reduce that to saying that the mean are the same. So no difference. So this is going to be mathematically, I'm going to write mean for plan 1 equals the mean for plan 2 equals the mean for plan 3. Now let me emphasize, I'm using mu, right? This is the true mean. We're not talking about, x bar 1, x bar 2, x bar 3, the sample mean. We can see if those are different or not. What we're really interested in is the true population mean for each of the 3 populations, being the population being people in each one of those plans. 3 populations. Okay, now let's go to step 4. Sorry, step 2. So this is the opposite of the original claim, and we're going to say that not all plans have the same weight loss. All right. Okay, and so what that is saying is that basically you could say there is an I and J, right? There's 2 numbers such that mu I does not equal mu J when I does not equal J. Okay, so I and J, so there's at least one pair that are not equal. Think about it for a second. That is exactly the opposite, saying that they are all equal. We're saying that just not all are the same. Okay, so let's go ahead and go on to step 3. And I need to find my null hypothesis and my alternative hypothesis. And so the null hypothesis is going to be this one, right? Because it has equality right there. So mu1 equals mu2 equals mu3. And then my alternative hypothesis is always the leftovers. And so that's going to be this thing right here, where we say not all are equal. Okay. Mathematically, if I wanted to do it, I would say there exists an I and a J such that mu1 does not equal mu J for I not equal j. So something like this would do. All right, but you don't need to write it in that sort of way with the existential quantifier there, with the existential qualifier. All right, so let's go now to step 4. Alpha equals, well, let's just use the default value there, 0.05. And then we'll go to step 5, and this is where we compute the test statistic. Okay, this is where we're hopping over to Excel, and this is sort of where the example from the book starts, is finding that test statistic. And to find the test statistic, we come up here. F is going to be our statistic for this test, and it's this ratio, right, of the variance that we see in between groups divided by the variance that we see within groups. Okay, so how do we find these? Well, the variance in between groups is this bit right here, which we can think of as associated with the variance of, so it's the variance that is described or explained by the groups. And so, you have a bunch of groups here, and they all have data values in them. And each one of these has its own mean. And so if each group is the same size, well, that makes things much easier. But if the groups are different sizes, then you have to take a sort of weighted average as you try and compute the standard deviation, or rather the variance of these means. And so that's what this is associated with. This is the difference in the variance in the means. And then what you do is you take the total. Now, another way of writing this thing right here is actually just, if you were to sum up x minus x bar squared, it simplifies to this. So this right here is the sum of square deviations for all of them. And so if you subtract the total sum of square deviations by the sum of square deviations described or explained from between groups, then you get the sum of squared deviations within groups. Okay, now let's just sort of catalog what it is we're going to need in order to compute this. So we're going to need S total, which is not too bad. That's just going to be the sum of squares of everything minus the sum of everything, which you'll recall is denoted by S. Where is S? S equals the sum of the individual sums. This thing right here is S. So you take S squared and you divide it by N, which is the total number. All right, so that's SS total. That's not so bad. Let's do SS between. SS between, you need the sum of these guys. It's J squared over N, J, and then minus S squared over N again. So notice that these terms right here are exactly the same terms. So since we're, subtracting them out anyway, we really don't need to compute those. We just need to take this difference minus this thing right here in practice. Okay, well, maybe we'll go ahead and do that then. So let's get our data. Weight loss, open in Safari so that I can download it. I'm going to download that there. Save. Open with Excel. Excuse me. And here it is. Okay, now what I would like to do is I'd like to write a bunch of formulas. I'd like to write a bunch of formulas and just save all of this, right? So I could use it again and again and again. And so that's what I'm going to do. So to that end, first I'm going to insert a column here. I'm going to come down here because the data values might be fairly long. I'm going to come down here. I guess I could always increase the length if I needed to. Come down here, and I'm going to start putting things in. So this is going to be my S. This is my SJ. This is going to be my NJs. Okay. This is going to be my SJ divided by, or my SJ squared divided by NJ. Right? That's what I needed for my between. And then what I'm also going to need is S and N. Just put these equal signs in here. That'd be nice. There we go. Okay, let's go back. Just make sure that we've got what we need here. Right? We needed those, and we needed the total sum of squares. Okay, so let's go ahead and take a look at that. So I also need my total sum of squares. Yeah, we actually don't need S right here, so I'm just going to put sum of squares. All right, great. So, oh, well, okay, but, yeah. So it would be good to have S here and there. Okay, so let's go ahead now and compute our SS between. Oh, there. Okay, so the SS between is going to be the total is going to be the sum of all the SJ squared over NJ minus the total sum of squares divided by N. All right, so let me put in a column here for the total sum of squares. I'll just do that, SS. Okay. So SS is the sum of squares. All right. Okay, so for this one, I'm going to do equals sum, and I'm going to add these columns right here. And for N, I'm going to do count. Count those. And then for this one, I'm going to go equals this squared divided by that. Enter. Okay, and now what I'm going to do is I'm going to copy these and I'm going to paste them. Copy these and paste. Okay, very good. Now for the sum of squares, that's just going to equal, or for the total sum, that's just going to equal the sum of, and I'm going to put all of these in. I'm going all the way down here in case I need to add data. I want this to be robust. I want to be able to use it with a lot of different data sets. Okay, so all that sums to 47. Let's go ahead and do the same thing with the count. There we go. Let's go ahead and add the sum of squares of everything. So that's going to be sum, and then notice there's this special formula here. Returns the sum of the squares of the argument. So that's what we want. And again, I'm just going to highlight everything, enter. There's the sum of the squares. Okay, now let's take the sum between. And so that's going to be this first term, which is the sum of all the sums squared over their sizes, and then divided by s squared over n. Subtract s squared over n. So here we go. Equals the sum of all of these, but minus s squared over n. All right, let's see, what did I, oh, because it's not n over n. All right, and so there's the, that's associated with the sum squareds just from the, from between. So now let's do total. And that's going to be just the total sum of squares minus s over n. So that's going to equal my ss minus s squared over n. Let's see, did I do the n again? Yeah, I did. There we go. And now for ss within. And that is going to be equals ss total minus between. Okay. So there we go. All right, now we need ms between, and that's going to equal that sum of squares between divided by, and this is going to be k minus 1. So I need to put in my total number of categories. So I'll maybe put that one right here, minus 1. So this will be k equals, this is going to equal count. Let's just, however many there are here. I guess we'll just go like that for now. Okay, and so there's my ms between. And now let's do ms within. MSW. MSW. And that is going to equal my sum of squares within divided by, this is going to be n, parentheses, n minus k. See that? Right there. Right there. N minus k. Close parentheses, enter. And so I finally get my F statistic, which is going to be, is going to equal that value divided by that value there. Enter, and I get 0.37. Now let's just go back here to our example. Now if I come down here, you'll notice this right here came right from the book. And you'll notice that all of our numbers match. Let me grab a screenshot here of all of this. This stuff right here. Copy and delete. Let's go ahead and paste it over here on the corner. Okay. So you'll notice we pretty much calculated everything correctly. Yeah, there we go. They do 4 decimal places. We've got a little more accurate than that. But, yeah, so there it is. Okay, so what that tells me is, is that my F statistic here is going to be 0.3769. And, but I don't have my p-value. I need my p-value. Okay, now these tests are always going to be right-tailed. And so I need to do my, so for the p-value equals, okay, here we go, equals f dot dis dot rt, because it's always going to be right-tailed. Put in my F statistic. My degrees of freedom for 1 is going to be k minus 1. My degrees of freedom for 2 is going to be the denominator, which is going to be n minus k. Whoa, don't type k. N minus k. Press enter, and there is my there's my p-value. So yeah, so p-value, step 6, p equals 0.6, what was it, 669? 699.1. Well, 699. There we go. Okay, and so step 7 then, I'm going to fail to reject. And so my step 8 conclusion for this one is going to be there is not sufficient evidence that's p equals 0.699 to suggest, well, now let's see, was my original claim the null hypothesis? And it was. So I'm going to say to reject. There is insufficient evidence to reject the claim that they were the same. Notice how much bigger the total variation, the variation within, is compared to the variation between. There was just a little bit of variation in between the groups, but there was a lot more variation within the groups. And so that right there tells you, yeah, you can't, that the variation in the means is not statistically significant. Or it suggests that, at least. Okay, so there is our full 8 steps there. Now, this video is fairly important because I am going to not rewrite all those videos, all those formulas on the next video. I'm going to reuse it. Okay, that should be good.